hello. Very good evening, good afternoon, good morning, sir. Same slogan you are saying daily. We are getting bored. Okay. How are you all, sir? Good, sir. Good. Now, in today class, I am going to start alcohol, phenol, ether, and in this topic, I will complete total about alcohol, like their method of preparation, their chemical properties, their physical properties, each and everything about the alcohol I will cover in this class. So this is the topic of total one sort of alcohol. Now basic things you already know कि CH3OH is 1 degree primary methyl alcohol, CH3CH2OH is 1 degree ethyl alcohol, CH3CH3OH isopropyl alcohol, CH3CH2CHOH CH3 secondary alcohol. This is 1 degree, this is 1 degree, this is iso, this is secondary. After that, ringa, chinga, pinga, hinga, linga, this is neo, ringa, chinga, pinga, hinga, linga, this is 3 degree tertiary, this is 2 degree, secondary means 2 degree, it is neo. After that, you know that whenever I will write over here CH2OH, it is known as 1 degree benzylic alcohol. Suppose I will write over here CH3CH2OH 2 degree benzylic alcohol. Over here CH3OH 3 degree benzylic alcohol. As well as you know that this alcohol is known as glycol and this alcohol is known as glycerol. So basic things you know about alcohol कि first one is 1 degree, second one is also 1 degree, this is iso, this is secondary, this is neo, this is 3 degree tertiary, this is 1 degree benzylic alcohol, this is 2 degree, this is 3 degree, this is glycol, this is glycerol. More than that, we didn't have to know about that much of alcohol. Now, after having this basic introduction that everyone is already familiar with, now I am going to start method of preparation of alcohol. And everyone will see this very properly. This topic I am going to dictate mains plus advance. Means after reading out this topic, you will not find any one of the difficulty in this topic. Means this topic will become the most easiest topic of all time. You will enjoy alcohol, phenol, ether if you will understood it what I am trying to dictate. Okay, sir. First of all, we are going to see method of preparation of MOP, means method of preparation of alcohol. Now, if we will have to prepare alcohol, what are the logic, what are the method we will follow to prepare alcohol? First method to prepare alcohol is see over here, either this lecture will go 1 hour or this lecture will go 2 hours or this lecture will go 3 hours. Not that much, but just I am saying I will dictate each and everything very properly. If you want to see it, see, otherwise you can go, no problem, choice is yours, there is no pressure in that. From hydrocarbon means what? Either it should be alkane, it should be alkene, or it should be alkyne. Basically we have to study from alkene. Okay, so there are 3 methods to produce alcohol from hydrocarbon. There are 3 methods to produce alcohol from hydrocarbon. First method is known as acid catalyzed hydration. First method is known as acid catalyzed hydration. Acid catalyzed hydration we will use dilute H2SO4 or we will use H plus H2O. Second reagent is hydroboration oxidation. High acid catalyzed hydration, short from ACH, acid catalyzed hydration. Over here, second one is hydroboration and oxidation. Hydroboration and oxidation. Hydroboration and oxidation covers a small short tricks is HBO, hydroboration oxidation. Third one is oxymercuration and demercuration. Oxymercuration and demercuration. Oxymercuration, demercuration, short form OMDM. Means there are three methods to produce alcohol from hydrocarbon. First method is called oxymercuration, acid catalyzed hydration, that is ACH. Second method is called hydroboration oxidation, that is HBO. Third method is called oxymercuration and demercuration. These all reagent will give what? Alcohol. First reagent has a property कि it will form carbocation. What it will form? Carbocation. And if it will form carbocation, then it will do rearrangement. I will do questions also, don't worry about it. But first I am writing all the important point. Second important point, reagent is H plus H2. Okay. Now over here, second reagent we have hydroboration oxidation. For hydroboration oxidation, the reagent we will use is first BH3 in presence of THF. THF means tetrahydrofuran. This is the structure, tetrahydrofuran. Plus second reagent we will take H2O2 in presence of NaOH. In this reagent you have to understood first important point that no carbocation. No carbocation. Over here carbocation is not formed, as well as Markovnikov rule we follow. Markovnikov's rule will be followed. Sorry. Hydroboration oxidation, anti-Markovnikov's. Over here we will follow. Acha, first one is to correct. No carbocation. No carbocation. Second important point, no carbocation means no rearrangement. Understood? Don't get confused. Third important point, it will do anti-Markovnikov's rule. Third important point, it will do syn addition. Hydrogenation, hydrocarbon, syn addition, anti-addition. Syn will taken as a positive, anti will taken as a negative, and cis will taken as a positive, anti will taken as a negative. That I will dictate, don't worry about it. Then last part of the topic is called oxymercuration demercuration. Oxymercuration demercuration, it will also not form carbocation. No carbocation. Why? Because of oxymercuration will form non-classical carbocation. In hydrocarbon I have dictated this. Then if no carbocation means no rearrangement. No carbocation means no rearrangement, and this will follow Markovnikov's rule. This will follow anti-Markovnikov's. This will form carbocation. Don't get nervous and confused. Now over here, see, I am writing some flow chart, then after that I will dictate the question also. Means what I am trying to say, कि first of all in acid catalyzed hydration, what is the reagent you are using? H plus H2O, or you are using dilute H2SO4. So SO4 is giving H plus, and dilute means water. Water is giving OH minus. Over here we are using the reagent BH3THF. On the top I have written this BH3 and THF will give H. BH3, THF not, and H2O2 in presence of NaOH. This H2O2 will give OH. Similarly in oxymercuration demercuration, we are using the reagent. First reagent we are using is HgOAc whole twice in presence of H2O. HgOAc whole twice in presence of H2O. Second reagent we are using is NaBH4 in presence of NaOH. You have to know कि over here H2O will give OH, and NaBH4 will give H. Understood what I am trying to say? I am saying that first of all, don't get confused. This is based and easy. First of all, I have dictated you the basic part of alcohol. What is 1 degree that I understood, sir. Now, method of preparation of alcohol from hydrocarbon. Hydrocarbon means what? Hydrogen and carbon containing compound will be alkane, alkene and alkyne. 3 reagent we will use: acid catalyzed hydration, hydroboration oxidation, and oxymercuration demercuration. First of all, in acid catalyzed hydration we will use dilute H2SO4 or H plus H2SO4, in which H2SO4 will give H and H2O will give OH. This you have to know. Similarly, over here, BH3 will give H and H2O will give OH. BH3 will give H and H2O2 will give OH. Similarly, oxymercuration demercuration, H2O will give OH and NaBH4 will give H. This part understood. Then it will form carbocation rearrangement. No carbocation, no rearrangement, anti-Markovnikov rule, syn addition. Very important. Then no carbocation, no rearrangement, because non-classical carbocation, Markovnikov's rule it will follow. If you will understood this flow chart, then on this basis of flow chart, I am going to write some example and we will try to solve it. Okay, sir, write it. First, see it very properly. What I have written, just understood. What I have written over here, like that. Okay, sir. Now why I have written this, see, understood it. Why I have written over here ki BH3 will give H. Suppose in hydroboration oxidation, they will write BD3 in presence of THF and H2O2 and NaOH. So what is the things coming? This will give D, deuterium, and this will give OH. Suppose I will change the reagent over here, D plus H2O. So this will give D, this will give OH. Suppose over here I will write HGOAC whole twice, D2O and NaBH4 NaOH. So what is the reagent coming? It will give OD, it will give H. So in place of H, they will change D. So you have to see where we will get OH. Suppose one will change the reagent like this. No sir, BD3 I will take THF, in presence of H2O2 I will take D2O2 in presence of NaOH. So this will give D, this will give OD. Understanding the point? So I have dictated what is the source of H and what is the source of OH. So BH3 is the source of H, NaBH is the source of H, and the H2SO4 is the source of H. Here source of OH is dilute, here the source or water, and here the source of OH is H2O2, here the source of OH is H2O. In place of H2O, if D2O given, they will write OD like that. I hope this much you understood, because you have seen my hydrocarbon topic, and hydrocarbon I have dictated you very, very properly. Okay, sir, we understood. Give some example to make us more understood. Okay. Suppose first question I have written over here. कभी कभी मेरे दिल में ख्याल आता है. Over here I have written H plus H2O. कभी 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 I have written first reagent as HGOAC in presence of H2O, and second reagent as NaBH4 in presence of NaOH. Suppose I have taken the third is first HGOAC whole twice in presence of CH3OH. Second reagent NaBD4 NaOH. Acha sir. Third I have taken the reagent as first reagent B2H6 in presence of BH3 whole twice. BH3 written or BH3 whole twice written, same. Don't get confused. BH3 whole twice also be written over here. BH3 BD3 whole twice or BH3 whole twice, like that they will write BD3 whole twice. That can be also written as B2H6. Don't get confused. Second reagent H2O2 in presence of NaOH. And one more, suppose I will take last reagent is first BD3 in presence of THF. Second reagent is H2O2 in presence of NaOH. Any problem? No, sir. Now see over here. First of all, what it will give? H and OH. First of all, what it will give? It will give, from here we will get OH, from here we will get H. Okay, sir. In this part, H2O is not there, so this will come CH3O minus. From here we will get OCH3 and from here we will get D. Understanding? Na? Suppose I will take this, from here I will get H, from here I will get OH, from here I will get D, from here I will get OH. Now understanding what I am trying to say. Now H2O2 will form carbocation. Carbocation means it will break minus plus. There is a possibility of rearrangement? No. H plus is there, OH minus is there. So H plus will attack on the minus side and OH will attack on the plus side. This product is come. But this product has one chiral center. One chiral center means it has two stereoisomers. One is normal, one is mirror image. The 2 will be the answer. Understood the point? Ha, sir. One on left side, one on right side. That much you know. Over here, it will form carbocation. Done. It is acid catalyzed hydration. It will follow Markovnikov rule. What it will follow? Markovnikov rule. Markovnikov rule is saying that more hydrogen will get hydrogen, less hydrogen will get OH or something what it is coming. So over here, what you will get? Ringa, chinga, pinga. More hydrogen will get hydrogen, less hydrogen will get OH. Markovnikov's. Sir, same as the first one, huh? Because no rearrangement possibility, so same coming. It also has two answer. One is left side, one is right side. Mirror image type. Acha, sir. Over here, what you will say? It will also follow Markovnikov's rule. Markovnikov's rule means more hydrogen will get hydrogen. But this time hydrogen is not coming. What is coming? D is coming. So what it will come over here? D. Acha. Over here, H2O2 will give OH. H2O will give OH. But H2O is not there. CH3OH is there. That will give OCH3. So this is the product coming. In this product again we have one chiral center over here. It also have two answer. Mirror image. Over here, it will follow anti-Markovnikov's rule. Lesser hydrogen will get hydrogen and more hydrogen will get OH. And this time at an OH is there. Is there any chiral center? No. So only one compound will form. BD3. It will also follow anti-Markovnikov's rule. What you will get? Ringa, chinga, pinga. Less hydrogen will opposite to Markovnikov's. Over here D will come. H2 needed to become, but H is not present. So what will come? D will come. What will come? D will come. So D will come here and OH will come here. Because over here D giving na, H not giving na. So it has chiral center. Yes sir, one chiral center over here because of D. So it will also give two product. Now understanding? Everyone? Any confusion? No sir, something coming. See it. Properly you will try to see it. Trust me, this is going to be very easy for you all. Okay sir, I am trusting on you. Second question, suppose I have taken कभी कभी एक था राजा एक थी रानी उसकी बेटी फूल कुमारी. Full same reagent I am taking from here. H plus H2O this. I am writing dash. How many I have make? 1, 2, 3, 4, 5 I have make. So I will make 5 lines. 1, 2, 3, 4, 5. Because I didn't have a space, so I will write all the time. That is a video, na? That will take most time. Same as line by line I have taken. First reagent what I have taken? H plus H2O. H plus H2O carbocation it will form. Carbocation it will break like this, plus and minus. Most stable carbocation, rearrangement not required. So it will come ringa, chinga, pinga, OH over here. H will be here, no need to write. If you want to write. Any problem? No sir. Does it has any chiral center? No sir. Because this carbon has this difference. But this side to coming same na. Nothing different. No chiral center. Only one product will be there. Second, what is the reagent I have taken? HgOAc plus H2O NaBH. For this I am writing Understanding na? हाँ sir, understanding. Over here it will give H and OH Markovnikov rule. Again Markovnikov rule, less hydrogen will get OH and more hydrogen will get hydrogen, only one product will form. Third reagent I have taken B2S6, H and OH, but anti-Markovnikov's rule. Anti-Markovnikov's rule means opposite to that. Over here coming what? 1, 2, 3, 4, 5. Third one is what? Acha, sorry. Third one is this one. This one. This I have written first one, second one, this one is third one. Third one is OCS3 and D. OCS3 and D. So over here OCS3 will come. Where OH is coming, there OCS3 will come. And where H is coming, there D will come. Oh, sir, over here 1 chiral center, 2 chiral center. Because of 2 chiral center, 2 to the power 2 is 4 is the total product coming. Next part, I have taken what? B2S6. Acha, anti-Markovnikov's rule. But this will do syn addition. What it will do? Syn addition. Written now over here especially for this hydroboration oxidation. Syn addition, syn addition. हाँ sir. So it will do syn addition. The problem is that we didn't know that this methyl is on base on dash. This methyl is where? This methyl is base or dash. So what you will say? That there is a possibility. I will think that this methyl, any one place I will think that this methyl is on base position. I will think like that. So what happened? H and OH has to attack by anti-Markovnikovs. So H will come here, OH will come here. Another product, you will think, no sir, it may be this methyl will be on base position, dash position. We didn't know na where it is. So sir, why you have not done in this part? Because in this part, no possibility, only cyclic ring is there, then you will do. Then what happened? Remaining hydrogen will be here on the base and OH will be here on the base. So base, OH, syn addition coming. Last part, it is giving D and OH. Again it is Markovnikov's rule, but syn addition. Again we will say, ki sir, we didn't know this CS3 will be on the base or this CS3 will be on the dash. So what I will do? I will say, okay sir, first I will put D here and OH here. D and OH coming. Second possibility that I will put this CS3 on the dash. So this D will come on the base and this OH will come on the base. Understood the point what I am doing it? Everyone? हाँ sir, understood. So 2 questions I have done. 2 more questions I will give you. 1 question I will give like this. All the reagent you will use. 1 question I will give like this. Here and here. First question, second question, homework question. Sir, what is the problem in first and second? No problem. First answer will be as it is, second will be as it is, third will be as it is. But whenever this will come, B2S6, H2O2, B2S6, H2O2, at that time syn addition, so syn plus trans, it is trans, so anti will come, syn plus cis, so it is syn will come. What will come? Syn will come. We will try to do that question and give me the comment on the comment section. If you have any doubt, I will dictate it again. Trust me. And I will dictate. I am not saying that I will need not see the comment and not say anything. I will dictate means I will dictate. Understood? So everyone will try this and try to understood this what I am trying to say and how is the one answer I will give. Suppose I will react with B2H6 in presence of THF and H2O in presence of NaOH, H2O2 in presence of NaOH. What you will say? Sir, over here CS3, this carbon, after that this carbon on the bottom CS3, it will do syn addition. It is trans is negative, syn is positive, positive negative will become negative. So there they will give H. So if H will come this side, they will give OH. So OH will come this side. Remaining 2 position already H is there. So this H and OH anti addition. Another possibility ki CS3, this OH will come this side, so H will come this side. Remaining H and H will be as it is. Understanding the point? This way happens. Anti-addition means H this side, so OH this side. It is cis, it is syn. Cis is positive, syn is positive. So for this CS3, H, OH, same side. H and OH will be same side. So over here, no possibility of doing other things. Understood? You can't do it. You will say, ki sir, CS3, OH this side I will not take. H and OH this side. You can take it, no problem. But whenever you will cross check, these two will come identical. These two will come identical. But over here, it will not come identical. Something it will come. Don't worry about it. So I hope. And remaining all will be as it is. So now I hope so. You will understood about the preparation of alcohol from hydrocarbon. Again, I am saying, if you will find any difficulty, 9267 937718 is my WhatsApp number. You can call, you can message me over here and ask me any one of the question if you are not able to get the solve. Understood the sir? Sir, we understood it. Okay. Now, some place I have changed D. Over here you can change D. Like that, lots of question you can make. I hope you understood. That much brain to you have. You are studying alcohol, phenol, ether, means you have already seen my lecture of hydrocarbon. You have already seen my lecture of GOC. You have already seen my lecture of isomerism. You have already seen my lecture of alcohol, alkyl and halide, alkyl and aryl halide. Then only you are coming here. If you have not seen, then suggestion. Trust me, I am giving very good content over here. I hope so. Lots of talented teachers are there in this universe. It may be they are giving much better than me. So you can see it over there also. It is not forceful. But if you are seeing from my lecture, the request, just a humble request, try to understood from beginning. If you don't want to see GOC isomerism, at least you will see hydrocarbon, as well as Grignard reagent, as well as haloalkanes, haloarenes, as well as electrophilic aromatic substitution. This 4 topic I have completed in one shot, as well as part by part also. Your choice. See, organic chemistry will become very easy. Now, next method of preparation is from alkyl halide. Next method of preparation of alcohol, hydrocarbon done. And I have given almost all the question possible that will be a chance of coming in the exam. So from alkyl halide. Now, in alkyl halide saying that suppose we have alkyl halide, they will react with NaOH, or this alkyl halide will react with H2O. So what it will give? It will also give OH, it will also give ROH. But you have to remind one thing, it will follow SN2 when R is 1 degree and 2 degree, and it will follow SN1 when R is 2 degree and 3 degree. When R is 2 degree and 3 degree, and SN1, SN2, sir, you are always saying to see that video, how I will understood it? If you know SN1, SN2, no problem. Not known, hydrocarbon, you will see I have dictated over there, total detailing. All nucleophilic substitution I have dictated SN1, not hydrocarbon, I have dictated that in alkyl and aryl halide, SN1, SN2, SN1 prime, SN2 prime, SN1 Ng, SN aromatic, SN2 aromatic, SN intramolecular, SNI prime, like that, lots of SNEA, SNAE, lots of things I have dictated. So if, sir, what happen if this is 3 degree, then 3 degree always, without any confusion, SN1. 1 degree always, without any confusion, SN2. If they are doing nucleophilic, if they are doing elimination, don't say that. Means nucleophilic substitution, 3 degree is always SN1, 1 degree is always SN2, but over here 1 degree and 2 degree will do SN2, and over here 2 degree and 3 degree will do SN1, NaOH and H2O is there. Acha sir, tell me some questions on this basis. Okay, suppose I have written the first question over here, कि we will have Me, CH2CH3, HCl, and I am saying react this first with NaOH, react this second with H2O. What you will say? Sir, this is 2 degree, one side methyl, one side ethyl, so it will follow SN2 and it will follow SN1, because 2 degree I have written, 1 degree to always SN2. Now SN2 means what? Inversion. Inversion it will do. Back side, what is the product coming? Me, bottom side is ET, CH2, CH3 is ET. H will come this side, OH will come this side. It will form inversion product, only one product, but it will form retention and inversion both. So it will form retention and inversion. What you will get? MEET HOH, one product, MEET HOH, another product. Two product will come because SN1 is there, and when you will put the mirror over here, you are getting this two product is looking like enantiomers. Enantiomers pair. The enantiomers pair will do racemic mixture, racemization. This is optically active, this is optically active, but racemic mixture is optically inactive. GOC, lots of things you know that already about this. Huh, sir? No need to dictate that. Trust me, what I am teaching, na. Acha, leave it. Don't show off too much, sir. Acha, okay. Suppose I have written over here Vase, methyl, and over here Cl, and I am saying react with NaOH first part, and second part react with H2O. NaOH will do SN2 because this Cl is 2 degree. It will do SN1. Acha. SN2 means inversion. CH3 will be not touched as it is, and Cl will go into outside and OH will attack, and that OH will attack on the Vase position, not on the dash position. Why? Because already Cl is on the dash position. For here, what you will do? First you will remove Cl, then it will become carbocation. After getting carbocation, it will do rearrangement. Over here hydrogen is there, they will break as a minus, it will become plus, hydrogen will come here. Don't say Vase and dash directly. So rearrangement happen. After rearrangement, it will become positive, and on this positive the OH will attack, and what you will get over here? Ringa chinga OH. Sir, over here Vase dash will not happen. No, because someone is already sitting on the Vase position. So if no one is sitting on the Vase, then Vase dash product OH will come. I hope you understood what I am trying to dictate regarding this. So second method of preparation also done from alkyl halide. Now we are going to see the next part of the topic, that is called reduction of carbonyl compound. Next method of preparation of alcohol is reduction of carbonyl compound, and trust me, I will make this topic that much easy. You will enjoy this topic if you will study very properly, and you already know little bit about GOC, hydrocarbon, all the things. Okay sir, okay sir, okay. So first topic we have seen preparation of alcohol from hydrocarbon, and second we have seen preparation of alcohol from alkyl halide. Third we are going to see from a reduction of carbonyl compound. Preparation of alcohol from the reduction of carbonyl compound. What is carbonyl compound? Just understood it. Sir, we know carbonyl compound. Okay, I know that you are talented, but still I will dictate you. Carbonyl compound means C double bond O is there. Over here something, over here something. Any compound that will contain C double bond O, that is known as carbonyl compound. Now, over here, whenever you will do the reduction of carbonyl compound, over there you will have to use the reagent as metal hydride. What do you have to use? Metal hydride. Metal hydride means M plus H minus. M plus H minus. And especially reduction of carbonyl compound we will do for aldehyde and ketone. Especially we will do the reduction of carbonyl compound for aldehyde and ketone especially, and reagent we will use as a metal hydride. What we will use? Reagent metal hydride. Before starting this topic, you have to understood over here that we have H minus, and any minus is known as nucleophile. If we will have any nucleophile, that nucleophile first wants to do acid-base reaction. Any nucleophile first wants to do acid-base reaction. After that, if acid-base reaction not possible, then they will do pi bond reaction. If pi bond is also not possible, then they will do sigma bond reaction. Understanding the point means any nucleophile H minus is there, they will first of all reduction of carbonyl compound, especially carbonyl compound is C double bond O, especially for aldehyde and ketone we will take over here reagent we will take metal hydride M plus H minus. Now before starting that topic I am saying if you will see any nucleophile, that nucleophile first try to do acid base reaction. If acid base reaction not possible, then they will try to attack on pi bond. If pi bond not possible, then they will try to attack on sigma bond. Not here, every place this is the power of nucleophile. Suppose I will give one example, R C double bond O OH. Now either you will take H minus nucleophile, or you will take R minus nucleophile, or you will take R del minus nucleophile, or you will take OH minus nucleophile. Any nucleophile you will take. First you will try to do acid base reaction, and this carboxylic acid has acidic hydrogen. It will react here, it will react here, it will react here, and it will react here. Everyone will try to do acid base reaction. It will give H2. It will give RH, it will also give RH, it will give H2O, but what is left? R C double bond O O minus, and you know that this R C double bond O O minus is doing resonance. Over here partial double bond coming, over here partial double bond is there, over here also we will have partial double bond, over here also we have negative, and they will do resonance over here, and these types of resonating structure is known as equivalent resonating structure. And equivalent resonating structure is a very good acidic strength. If after removing hydrogen any compound is giving equivalent resonating structure, it means that compound is good acidic nature, good acidic nature. Why? Because after giving acid, that is H plus, it is forming the equivalent resonating structure, so it is a very good acidic nature. So over here, if possibility, then it will first try to do acid base reaction. If no possibility, then it will not try to do acid base reaction. Okay sir. So carboxylic acid to doing acid base reaction. Suppose I have taken aldehyde C double bond OH and ketone R C double bond O R. Now tell me over here any place acidic hydrogen? No acidic. Don't say this is acidic. Acidic hydrogen means after removing hydrogen, that will be stable. No acidic hydrogen is there. Okay. But this carbon and oxygen has electronegativity difference. Because of that, it will get little bit del plus, it will get little bit del minus, it will get little bit del plus, it will get little bit del minus. Now what happened? Ki H wants to attack over here, H minus is there. H also wants to attack over here. Now H wants to attack over here. This side CS3 is giving plus I effect. R is giving, understood. I am saying over here acid base reaction is not possible. If acid base reaction is not there, then it will try to attack on pi bond. It will try to attack on pi bond. So over here pi bond is there. Pi bond, it will take little bit negative charge, positive charge due to electronegativity difference. Now H minus will try to attack over here. H minus will try to attack over here. Now whenever it is trying to attack, what will happen? This before attacking, before H plus will attack, what is happening? Del plus creating, del plus will be stable over here by R plus, but it is stable over here by both side R plus. So it will say, okay, no problem, I am little bit stable, attack little bit slow, no problem. As well as it has less steric hindrance, it has more steric hindrance. So which has more rate? Aldehyde. It means rate of reduction of aldehyde to form ketone is more than, rate of reduction of aldehyde to form alcohol. It is forming what? Alcohol. Rate of reduction of aldehyde to form alcohol is more than ketone. First reason is what? Due to less steric hindrance. Due to less steric hindrance. Due to less steric hindrance. Why? Because over here only one side R is there. Over here two side. Second important point, this plus is not stable because only one side. This plus is more stable. So due to high electropositivity in aldehyde, due to high electropositivity. So in aldehyde, less steric hindrance and high electropositivity. So aldehyde has more reduction capability in presence of H minus as compared to ketone. So I hope you understood this. Now you can write over here one short tricks, but don't believe on short tricks. I will dictate it also. And dot short tricks is that ki aldehyde, whenever it will react with metal hydride, it will give 1 degree alcohol. Aldehyde react with metal hydride, it will give 1 degree alcohol. But whenever ketone react with metal hydride, it will give 2 degree alcohol. It will give 2 degree alcohol, and this is the important part of the topic. Now, sir, you said it is the short tricks, but I don't want the short tricks. Dictate me how you are saying it. Suppose I will take aldehyde, C double bond O H. First reagent H minus is coming. What is coming? H minus is coming, and second reagent H2O is coming, and it will convert into RCH2OH. How, sir? Reaction you have written directly. Let me understood also. Okay, don't worry. RC double bond OH is there. First of all, H minus will come. H minus you have already seen this has del negative. Little bit it has del positive, negative it has del positive. On this del positive it will attack. Once it will attack, RCH is coming. Over here H, carbon is getting one more bond, so it will break. Carbon does not make 5 bond, so it will become RCH H and O minus. O minus say, no, I want to return back, give me some space. So this H will say, no, I am not a living group. This H will say, aisa, bhai sahab, I am also not a living group. This R will say, nahi bhaiya, I am totally not a living group. So this O minus is totally worried. So at that time, H2O will come, and H2O or NH4Cl. Both will give H plus. How? H2O, so we know that, sir, H plus OH minus. How NH4Cl? NH4 plus Cl minus, then NH4 plus converted into NH3 plus H plus. So both is the donor of H plus. Once the H plus will come, it will become very happy, and it will become R, C, OH, H and H. And you have seen over here कि I can write this R, CH2, OH, and this alcohol is 1 degree alcohol. So I have written कि aldehyde will give 1 degree alcohol. Acha, suppose we have ketone. Ketone we have RC double bond OR. Now again H minus will come first from metal hydride. What are the metal hydrides, sir? Wait, I will dictate it. H2O will come. What will happen? First of all, it will get del negative. H minus will attack. It will get more bond. Minus will attack. It will give H plus. H plus will attack, and you will get R, C, OH, over here H and R, and it will give 2 degree alcohol. So I hope you understood the reduction of alcohol, reduction of aldehyde and ketone to produce alcohol. Now question arises, what are the metal hydride we will see? So what are the reducing agent that we will see as a metal hydride? And we are going to talk about the metal hydride. That metal hydride is act as a reducing agent because it is giving H minus to the compound, and H coming is what? Reduction. So metal hydride is a reducing agent. What are the reducing agent and what are the metal hydride we are using over here? Just see it. What first metal hydride I am using? Very important. First metal hydride I am using over here is कभी कभी मेरे दिल में LiAlH4, that is also written as LaH. LiAlH4, that is also written as LaH. Li plus, and it will give Al, H, 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 and aluminum has minus. Over here H will go, minus will go from here, and it is more reactive. And it has 4 hydrogen. So how many hydrogen required? It will give, and it can reduce each and everything. I will tell you what. First LiAlH4. Second one, is NaBH4. That can be written as SBH, sodium borohydride. Sodium borohydride. If you will draw the structure same, NaBH, H, H and H, it will get over here minus sign. The hydrogen will go from here, minus will be stable. So, but understood the point. It will only react, means SBH has also lots of hydrogen. I will tell why I am saying lots of hydrogen. I will tell that also. First understood this part. With question I will understood. It can reacts only with aldehyde, ketone, acid halide. Acid halide. Acid halide is C double bond O Cl and C double bond N, that is known as imine. Rather than that, it will not react with anyone. This is fixed. This is totally fixed. These four only it will react: aldehyde, ketone, acid halide and imine, C double bond N. Remaining it will not react. It also has lots of hydrogen source. Fourth one is dibyl H. Dibyl H. That is also known as, dibyl H means di-isobutyl aluminum hydride. Dibyl H means di-isobutyl aluminum hydride. That is also written as aluminum isobutyl whole twice and hydrogen. Sir, what is the structure? Aluminum is there, here hydrogen, over here isobutyl and over here isobutyl. Di-isobutyl aluminum hydride or hydrogen Al, over here isobutyl means 1 2 3 4, over here 1 2 3 4, di-isobutyl aluminum hydride. Now it will give also hydrogen because it has more bond, it will give hydrogen, and over here only one H, only one hydrogen. It has 4 hydrogen, it has 4 hydrogen, but di-isobutyl aluminum hydride has only one hydrogen. What is the use of that? That I will dictate it. Fourth reagent we have is B2H6 in presence of THF, that is also written as BH3. Next reagent is H2 catalyst. H2 catalyst will do adsorption hydrocarbon. हाँ sir, what is there? RC double bond O, RC double bond O, C double bond O and H is there. What you will do? You will take nickel or platinum or palladium catalyst. Over here hydrogen molecule you will put, this 2 will come and hydrogen will attack over here, hydrogen will attack over here. They will do syn, and over here rate is more in palladium, then platinum, then nickel. Nickel will do little bit slow. So these are the total 5. These are the total 5 metal hydride, that is reducing agent. In that LiAlH4 is very more reactive. This NaBH4 will only react with this 4, and dibyl H has only one hydrogen, and remaining 2 is B2H6 and THF and H2 and catalyst. Understood? Now on this basis I am going to do some questions, then we will go with the further topic. Suppose first question I have taken, न जाने मेरे दिल को क्या 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 हो गया. कुछ नहीं हुआ सर, आप ऐसे ही बेचैन रहते हो. उम्र हो गई आपकी लेकिन दिल अभी भी धड़कने को तैयार है. अरे बच्चों के रिजल्ट के लिए धड़कता है, आप लोग तो पूरा यू आर वेरी डर्टी माइंडेड. अरे नो सर, वी आर नॉट. सपोज ओवर हेयर फर्स्ट reagent I have taken LaH. Second reagent I have taken H2O. Second part. Over here first reagent I have taken SBH means NaBH4. Second reagent I have taken H2O. Over here third reagent we have taken, first part is suppose B2H6 in presence of THF, and second reagent is H2O. Over here, third reagent we have taken, suppose first one NaBH4 and second reagent is D2O. Fourth reagent we have taken H2 in presence of nickel, and fifth reagent we have taken diable H in presence of H2O. First reagent, second reagent. First question. Second question I have taken like this, kabhi 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 double bond O, ringa chinga CHO, ringa chinga pinga COO CH3, and I have taken two reagent only over here. One is NaBH4 first reagent and second reagent is H2O. Over here I have taken first reagent LiAlH4, second reagent is H2O. Now what I have taught, on this basis I am going to solve these two questions, but I am going to give you one break. What is the break? Break is the stoppage of this topic. Already 50 minutes is there. Those who have reached up to this, they can just see it properly. After that I will continue this topic in next lecture. Understood? Sure short? हाँ sir, understood. Means these two questions I will do, but not in this lecture, next lecture. So up to this you will revise. Next lecture you will see how I am doing it, because already 51 minutes completed. So I don't want to give you that much more. So up to now you will revise. These two questions I will solve in the next lecture. Okay. Bye. Have a nice day. Hello. Very good evening, good morning, good afternoon, whenever you are watching this lecture. So in the last lecture, first I have dictated you what is the basic concept, introduction of alcohol. After that, method of alcohol from hydrocarbon, acid catalyzed hydroboration, oxidation, oxymercuration, demercuration, and that basis I have done 4 questions. From alkyl halide, NaOH, something like that, I have dictated you SN1, SN2. Sorry. After that, reduction of carbonyl compound, and I have told you nucleophile always try to do acid-base reaction. After that, it will do pi bond and then sigma bond. And then I have dictated aldehyde will give 1 degree alcohol, ketone will give 2 degree alcohol, and then I have written 5 reducing agent as LiAlH4 more reactive. After that, NaBH4 only react with aldehyde, ketone, acid, halide, and amine. Diable H, only one hydrogen is present, B2H6 and H2 catalyst. Then over here we have this structure. One question is there. If you have any confusion, you can see the previous lecture, it is good. Now one question I will dictate from here. Suppose this is aldehyde, ringa, chinga, pinga, hinga, linga. Over here C double bond O, H is there. You already know it will give H minus, it will give H plus, it will break like this, it will get minus, it will get plus. On this plus minus will get, and on this minus plus will get. Means overall, if I will write one thing over here, so I hope everyone will understood. And that thing is that reducing agent gives H minus 2 carbon. Reducing agent will give H minus 2 carbon, and water will give H plus 2 oxygen. H minus coming to carbon and H plus 2 oxygen. So similarly it will give H minus, it will give H plus. What is the product coming, sir? Over here carbon getting one more hydrogen, so CH2, oxygen getting hydrogen, OH alcohol. Similarly over here O will get H, this carbon will get hydrogen, but in the bond line structure we are not showing hydrogen. If we will not show it, it will be as it is. In this same answer will come, but over here D2O written, not written H2O. Over here H2O, no problem. So what happened? D will give hydrogen H2O will give hydrogen to oxygen. So this carbon will get hydrogen, but oxygen will get deuterium because D is there. Acha, over here, this carbon will get hydrogen. No need to show this hydrogen, but this oxygen will get OD. Understood the point? Ha, sir. Not get confused. This part as it is. Over here, ring is there. In that ring, it will get CH2OH. It will get OH. Double H, H2O, same answer. So I hope you understood this question. Those who didn't able to understood, either you will see one shot when I will upload it, or see the first lecture and come over here. Now, next question. I have told you that NaBH4 can reduce only C double bond N, aldehyde, ketone and acid halide. Acid halide. Rather than that, it will not reduce anything. So over here, aldehyde, yes, it will reduce to alcohol. Structure you will draw. Alkene, so no one will talk. It will become alcohol. Aldehyde here, yes, it will also become alcohol. CH2OH. Ester is there. No touching, sir. No touching. It will be as it is. COOCH3. But LiAlS4 is very strong reducing agent. It can reduce aldehyde, ketone, ester, everything. But it will not touch alkene. So alkene will be as it is. It will become OH. Aldehyde will also become OH. And this will become CH2OH. How, sir? How it will become CH2OH? That we will see just after this when I will dictate you. Okay, sir. So I hope you all understood up to now. If you have any confusion, I am already giving all the time my number 9267937718. And don't worry, after completing organic chemistry and that we are able to go, right now we are on alcohol phenol, thereafter at aldehyde and then amines. I will do lots of questions. Don't worry about it. Question and question only. You will enjoy the concept. Okay, sir. Now, next part of the topic, and the name of the topic is called reduction of from reduction of ester. From reduction of ester. Just see it very properly. Yes, sir, we are seeing it. Why you are saying see it very undertake? Okay, sorry. Now, over here, we have R, C double bond O, O, R dash. R dash means R will be same or different. Over here, H minus will come. You know that where the H minus is going? Acha. H minus is going to, suppose I will take both H minus and H plus. H minus coming from reducing agent like LiAlH4, NaBH4 or B2S6 or H2 catalyst or double H. Okay. Now you know that ki H minus will come to hydrogen and H plus will come to oxygen. It will become RCH2OH plus R dash OH. From where it is coming, sir? From where H plus to coming, sir? From H2O, no doubt. H minus, sir, H minus source R. You have just now written LAH. Yes, it is there. Second, you have written SBH, NaBH4. Sir, it is not there because it is only applicable for aldehyde, ketone and acid halide and amine. So this will to not give. Acha, sir. Next, you have written ki H minus will come from double H. Double H. But it has only one hydrogen. So what is coming? So it will also not there. I will write the mechanism also. Don't worry. It is also not there. Why, sir? One hydrogen it will give, na? But one hydrogen is there. It required two hydrogen. Why this colaveri? Just wait. LAH, okay, for reduction of ester. SBH, no, because ester it is not applicable. Double H is applicable on ester, but it is also no. Why no? I will dictate. Next one, B2S6 in presence of THF. हाँ sir, yes. Sir, next one, H2 catalyst. हाँ sir, yes, without any doubt. It means for ester we have B2S6 THF, H2 catalyst and LAH. Only three. Why not double H, sir? Don't worry, I will dictate you why this colaveri D with mechanism. Okay, sir, how many times we will say that? Okay. Now, see over here. What is happening? If you will understand the mechanism of ester by using the reducing agent, what you are getting? Over here you have ester, R, C double bond O, O, R dash. First of all, what happened? Carbon and oxygen, there is difference electronegative. Due to electronegative difference, it will get partial positive, it will get partial negative. After seeing positive on carbon, H minus from reducing agent. What are the reducing agent? Sir, LAH. Okay. SBH. No, sir. Sir, B2S6 in presence of THF. Okay. Sir, hydrogen plus catalyst. हाँ सर, ओके सर 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 डाइबल एच. हाँ सर, ओके. जस्ट नाउ यू सेड नो. वेट राइट नाउ. ओके. This H minus will come here. As this H minus will come here, carbon getting one extra bond, so this will break from here. Carbon getting one extra bond, it will break and it will become O minus O R dash. Ab now oxygen na. Oxygen is that compound. If you will get minus over there na, it always wants to return back. Previously, whenever we are doing for aldehyde, it is not able to get return back. Or I will dictate you later, it will not able to get return back, but it will return back whenever there is a living group. What is the living group? Like Cl is there, like Br is there, like F is there, like Or is there, like OH is there, something living group na. So it will come and it will leave. Once it will leave, what you will get? R, C. Now see over here, double bond O and one hydrogen, and R dash O minus will be outside. Any problem? No, sir. If you are using diable H, reaction stop up to this. Reaction stopped up to this diable H. But you know that aldehyde will also convert it into alcohol. We are using the preparation of alcohol. So diable H can proceed the reaction up to this, because diable H has only one H minus, no other H minus. The reaction will not proceed further. But if you have to proceed further the reaction, you have to use the reagent like B2H6 THF or H2 plus catalyst or LiAlH4. LiAlH4. This has too many hydrogen whenever I am writing the reagent. Again, these all reagent will give H minus. Once it will get H minus, what will happen? Over here again, partial positive, partial negative. This H minus will come here. It will become R, so it will break the bond, oxygen. So first not breaking the bond, first becoming partial positive negative. Why? Because of electronegativity difference. After that, hydrogen will attack, then it will break the CO minus bond. O minus, H is there, H is there. Now I have told you कि oxygen wants to return back, but it not able to. Hydrogen will say, nah, I am not a living group, I am very happy with my girlfriend. Hydrogen will say, nah, I am also happy with my girlfriend. Carbon, R will say, no, I am also happy with my girlfriend, I don't want to go outside. It means hydrogen and alkyl are not living group, so oxygen is not able to return back. If there is a possibility, then first it will try to return back. But no possibility, no return back. So what happened? Now we have to provide water. Water will give H plus, so it will become R. Carbon has two hydrogens, CH2, and oxygen minus will get OH. And as well as outside you have R dash O minus. If H plus will come, so it will also become R dash OH. Because water has 2H, so it will give 2H, no problem in that. Don't see the byproduct, but product is coming alcohol. So this reagent can able to go up to alcohol, but diable H only up to aldehyde from ester, and SBH to not applicable. Understood? So this is all about the preparation of alcohol from the reducing agent. And sir, I am doing too much of hard work. I will not say you to subscribe my channel and give me the view. No. But I will suggest everyone means everyone, those who are watching my lecture, it's a personal request to everyone. If you will like my lecture, see first what are the lecture you will see. I will write over here. One lecture you will see, I have written the heading, some basic concept of chemistry. This lecture everyone will see. Then I have written hydrogen bond. This everyone will see. Then I have done hydrocarbon. Everyone will see. Then I have done electrophilic aromatic substitution. Everyone will do. Then I have done Grignard reagent. Everyone will see. Then I have done haloalkanes and haloethers. arenes, everyone will see. Why this cola very, sir? Why you are saying to see all this? Trust me, you will become very good in organic chemistry, sir. Very good. I am not saying I have taught very good, no one is teaching like that. No, it may be someone is there who is teaching much farther better than me. But only one thing I will say, over here every lecture I have completed in very short interval of time. And time is very important. Instead of 20 hour, 10 hour, I have done in 1 hour, 2 hour, like that. And no topic I have left. Okay, sir, I understood it. Whenever I want, I will see it. If I don't want, I will not see. Don't give me the logic to see this, that, this. You teach, I am here to study alcohol. Okay, sorry. Now, next method of preparation of alcohol from Grignard reagent. Now, those who have already studied Grignard reagent very properly, they will not find any difficulty. Sir, I have not studied. Then what I will do? I am going to teach over here. Grignard reagent will follow nucleophilic addition reaction. Grignard reagent will follow nucleophilic addition reaction or nucleophilic addition over elimination. If aldehyde and ketone is there, nucleophilic addition reaction. If ester is there or acid halide is there, then acid halide means C double bond OCl or ester, then nucleophilic addition over elimination. Understood? Now we are going to see. First of all, you already know everyone means every. From Grignard reagent, we know that Grignard reagent is Rx plus Mg. Grignard reagent I have dictated one shot, but don't worry, those who have not seen, they will able to understood it. I will not say to see the topic of Grignard reagent one shot. No. See over here. You know that it is forming R, Mg and X. This is known as Grignard reagent. In that you already know that the bond over here is covalent bond. The bond over here is covalent bond. And the bond over here is ionic bond. And we know that if anybody is asking bond strength, so we know that bond strength of ionic bond is more than covalent bond. So whenever it will break, it will break as R minus, means here it will break minus plus MgX. Means again R minus coming. R minus coming means nucleophile coming. And in the previous lecture, I have dictated you of alcohol phenol ether कि whenever nucleophile will come, first it will try to do acid base. First it will try to do acid base reaction. If acid base reaction not possible, then it will try to do attack on pi bond. And if pi bond is also not there, then it will try to attack on sigma bond. Line by line you have to go. So this is all about Grignard reagent. Suppose see, don't worry about it. Okay, sir. Suppose first example I have taken OH, ringa, chinga, pinga, hinga, linga, Cl. Now over here, first Grignard reagent will come. Suppose I have taken CS3 MgBr. What happened? It will break from here. It will get minus. It will get plus. This minus is waiting for acid base reaction. So I have dictated you NaCons QHX, nitroalkane, acetylene, terminal alkyne, oxygen, nitrogen, sulfur, quasi-aromatic and HX, HCl, HBr, HI in Grignard reagent. Leave that. But you know that this is acidic hydrogen. It will break as a plus and minus. So what happened? This hydrogen will attack on here. First it will do acid base reaction and minus will attack here. Plus will attack on oxygen and minus will attack on hydrogen. What you will get? CS3 will get one hydrogen and this total compound O is there. With that Mg will attack Br. 1, 2, 3 and over here Cl. Acid base reaction done. First it will try to do acid base reaction. Done. Over here minus, over here plus. Now no pi bond over here in this structure. Now it will search for sigma bond. This minus searching here. Any plus coming? No. Here any plus coming? No. Here any plus coming? No. Here plus coming? Yes. Because of electronegativity difference. Because of electronegativity difference, it will get del minus, it will get del plus. This oxygen will say, I bhaiya, del plus, I want to come here. When this oxygen will come, chlorine will go outside. Means, what will happen? One carbon, second carbon, third carbon, fourth carbon, and this 2 carbon is connected with oxygen. And outside MgBrCl. Sir, not understood. Again. What happened? Once the Grignard reagent, first so it will try to do acid base reaction, done. Then pi bond reaction. Is there any pi bond? No. There's sigma bond. This minus is searching for some negative, positive charge. Here positive, no. Here positive, no. Here positive, no. Here yes. Due to electronegative difference, it will attack here. Cl will go outside. Once it will attack oxygen here connected with this carbon. So these 2 carbon is this and this oxygen is connected. Remaining in between that 1, 2, 3 carbon. So 1, 2, 3 carbon. Means overall 1, 2, 3, 4 carbon. So 1, 2, 3, 4 carbon. 1, 2, 3, 4 carbon. And on the first and fourth, oxygen is attached. And this structure is known as THF, tetrahydrofuran. One more example, sir. One more example. Okay. Suppose I have taken second example. Ringa, double bond O, chinga, hinga, linga, Cl over here. Now, first it will over here, suppose I will take CH3 MgBr. It will break as minus plus. First it will try to do acid base reaction. Is there any acidic hydrogen? No, sir. Acid base reaction not is there. The pi bond. Sir, pi bond is there. Over here due to electronegativity difference, del plus, del minus. After seeing this plus, it will come here. As this will come here, carbon getting one extra bond. 1, 2, 3, 4 bond is already there. So if CH3 will attack, one extra bond will come. This carbon will break as a minus charge. After seeing this minus, it will attack over here. What will happen? Ringa. Over here oxygen. With oxygen, MgBr. Over here with this carbon, CH3 coming, remaining as it is. Now, so acid base reaction not done. Pi bond reaction done. Plus, minus. Now this oxygen is searching. Over here plus. Nah. Over here means this oxygen minus is searching for some plus. Over here plus, na. 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 Over here plus. Yes, sir. Del plus, del minus due to electronegative difference. So this oxygen will try to attack over here. As it will attack, chlorine will go outside. Leaving group. Always, because 2 hidden hydrogen not showing means extra bond coming for carbon because hydrogen is there. Hydrogen we are not showing but present. Na. So what happened? 1, 2, 3, 4 carbon. So 1, 2, 3, 4 carbon. And on the first and fourth carbon, oxygen is attached. But from where? First carbon. This is first. 1, 2, 3, 4. Or on the first carbon, 2 methyl group is there. So this is the answer coming. 2 methyl group is there. This 2 methyl 1 and 2. Understanding? Ha sir. Something though coming. Understood? Suppose. Instead of Grignard reagent, I will change the reagent. And I will say कि Ringa, double bond O, chinga, pinga, Br over here. And I am saying react with NaBH4. That is also written as SBH. We know that NaBH4 will give H minus. Again nucleophile. H minus is nucleophile. Searching for acid base reaction. Possible in this? No. Double bond? Yes. Del plus, del minus. H minus will attack over here. It will attack carbon getting one more extra bond. It will break. Once it will break, what you will get? Ringa, chinga, pinga, hinga, linga, oxygen. Ringa, oxygen minus. Over here, hydrogen will come. No need to show, but I am showing over here. Oxygen has 2 possibilities. Either it will return back. No, sir. No returning back because this total is not a living group. If no returning back, then this oxygen is searching for plus charge. Over here plus? No. Over here plus? Yes. Due to electronegative difference. So this oxygen will attack here. This is 1 number. This is 2 number. Br will go outside. What is the product coming? Ringa, chinga, pinga, hinga, linga. This 1 number and this 2 number. 1 number oxygen attached with 2 number. This is the answer coming. I hope you are understanding. Ha, sir. We understood little bit about Grignard reagent. More you have to understood. Then you will see Grignard reagent 1 shot that I have dictated in 1 hour 40 minutes approximately. Now sir, you are doing something bakwas, but we are over here to prepare alcohol from Grignard reagent. Heading is preparation of alcohol. Yes, I am coming. First I have dictated little bit what is Grignard reagent and how it will attack everything. Before going for the preparation of alcohol from Grignard reagent, first I am going to write some shortcut. In that shortcut you have to understood कि if there is formaldehyde is there, formaldehyde will always give 1 degree alcohol. If other aldehyde, if other aldehyde rather than formaldehyde, it will give 2 degree alcohol. If ketone is there or acid derivatives, what do you mean by acid derivatives? I will dictate you. Acid derivatives is there, both will give 3 degree alcohol. Sir, ketone, aldehyde, formaldehyde, we know that ki sir, formaldehyde is HC double bond OH, that also written as SCHO. Other aldehyde will be RC double bond OH, that is also written as RCS2. Ketone also we know RC double bond OR, that is written as RCOR. But acid derivative means RC double bond O, something is Z. If you will put Z over here, H, it will become carboxylic acid. Cl, acid halide, H, aldehyde. Cl, acid halide. OH, carboxylic acid. NH2, amide. Br or Cl, like that. Anything you will put over here, lots of things is there. Either you will put NHR or you will put NR2, like that. It will give carboxylic acid. It will give amide, like that. It will give acid chloride. It will give aldehyde. So like that, anything will be there with C double bond O. So now all will give alcohol. Now, sir, short tricks we don't want to study. Short tricks, we have learned short trick, but dictate me how this colaveri. Okay. First I will take formaldehyde, SC double bond OH. I have taken some Grignard reagent, RMgX. What will happen? First it will break as minus and plus. Now this minus is again nucleophile. Searching for acid base reaction, not possible. Double bond reaction, yes sir. Del plus, del minus, due to electronegative difference. It try to attack over here. Once it will attack, carbon will get extra bond. Oxygen will get extra bond. When carbon will get extra bond, so oxygen will break. This will come here. What you will get? H, C, O minus, over here R, over here H, and on the O minus, MgBr is coming. Now what happened? Oxygen has chance. It wants to return back. Either it will return back or it will search for living group. Hydrogen is not living group, hydrogen is not living group, alkyl is not living group. When no living group is there, then we have to provide H2O. H2O will give H plus OH minus. Once it will give H plus OH minus, H plus will come to oxygen and OH minus will go to MgBr. What is coming? H, C, over here OH, H and R, and outside MgBr, OH will come. What is the product coming? R, CH2, OH. This is known as 1 degree alcohol. Now, in the previous part, whenever we are using reducing agent, we are not getting 3 degree alcohol. Written 3 degree alcohol cannot be prepared. But over here I am writing, 1 degree alcohol prepared, 2 degree prepared, but 3 degree not prepared. Why this colaveri here? Because some extra R is coming from Grignard reagent. Previously H is coming from NaBH4 as a nucleophile. This time nucleophile is also itself a alkyl group, so it will increase the degree, so 1 degree. Similarly, I will take another example. Suppose RC double bond OH and same reagent RMgX. Now I will not dictate in 2 steps what happens. 1 step I have dictated. Second step I will take H2O. What will happen? R over here, OH will come over here H, and what is R over here? That will attack over here. So you will get 2 degree alcohol. Second part, if I will take third example RC double bond OR. Again I will take first reagent as RMgX, second reagent as water. What will happen? RC, it will convert into OH, R, and this R minus will attack over here. 1 extra R will come. So formaldehyde is giving 1 degree alcohol. This is detailing I have done. Other aldehyde will give 2 degree and ketone is giving 3 degree. Fourth one I have written acid derivatives, means RC double bond O. Some living group acid derivatives are what? Cl, this is not acid derivative because it will become aldehyde. Cl, OH, NH2, NHR, NR2, these all are very good living group. So this living group is there. Whenever you will take Grignard reagent RMgX, what happened? This minus plus, first it will attack over here. Once it will attack RCO minus MgX, and over here R, and over here living group. This time oxygen does not want oxygen, hydrogen. This time oxygen does not want water because this living group is present. First oxygen wants to return back. -2 double bond. Not possible, then searching for living group like Grignard reagent previous. If not possible, then water will come. So living group is there. So what you will get? R C double bond O. R is there plus this MgX and this living group will go outside. MgX living group. So you will write it properly. R C double bond O R. Again it will become ketone. Again you will use Grignard reagent. R MgX. It will become what? RCO minus MgX. Over here R. Over here R. Again oxygen wants to return back, but no possibility. This time no living group. So I have to provide him water. So what it will become? RCOH. R is there. R is there. MgX. OH will go outside. Their name is magnesium hydroxyhalide. Magnesium hydroxyhalide. So you understood what? Whenever no living group is there, how many mole of Grignard reagent you have used? 1. Whenever one living group is there, how many mole you have used? 1 over here and 1 over here. 2. Suppose I will give example C, Cl, Cl and double bond O, H I have taken. Now I am taking Grignard reagent RMgX. What happened? First it will break as minus, plus, it will get del plus, del minus. On this plus it will attack, it will break. X will come. Cl, H is there. It will get R. Over here OMgX. Oxygen wants to return back. It will say yes, you can return back because Cl is a living group. What you will get? C, 1 Cl left, 1 H is there, 1 R is there. Oxygen coming back, O coming. MgX, Cl will come. Understanding? Again you will use Grignard reagent RMgX. Again Grignard reagent will see it will break as minus plus, it will break as plus minus. R minus will attack over here, it will break like this. So what will you will get? C, Cl is there, H is there, R is there. One more R is coming. Then OMgX. Again oxygen wants to come back. This time living group. Yes, again living group is there. Cl will go outside. So R, CH, double bond O, 1 R is there, this R, CH and double bond O coming outside. Again MgX, OH will come. Then MgX, Cl will come, not OH, Cl will come. Again Grignard reagent will come, RMgX. We will get R, CH2, OH, R, CH, over here OH. Over here 1 R and 1 more extra R is coming, so no H is there. What you will get? Understanding the point. Sir, slowly we are understanding what you are trying to say. See it 1 to 2 times, it will become very easy. Means all the time Grignard reagent is giving R na, so previously it does not have any R. After that 1 R will come. After that 2 R will come. After that 3 R will come and it will convert it into alcohol. So this time it has how many living group? 2 living group. Grignard reagent, 1 here and 1 here. 1 means no living group, only 1 Grignard reagent. 1 living group, 2 Grignard reagent. 2 living group, 3 Grignard reagent. So sometime they will ask how many moles of Grignard reagent is used. So number of RMgX, that is Grignard reagent consumed in any reaction, is equals to number of living group plus 1. 1 living group, 2 Grignard reagent. No living group, 1 Grignard reagent. 3 living group, 4 Grignard reagent. And in Grignard reagent, I have solved lots of questions regarding this also. Lots means lots of questions. You have seen it already, I hope so. Not seen, then see. I am always saying everyone, see that lecture without any doubt. Sir, one question they will give like this. Over here some compound is there A. And that will react with R-MgX. Now product is coming something like this. This given. Now they are asking what is A and what is R dash. Tell me. So you will say in Grignard reagent something is attacking. Either this is attacking or this is attacking or this is attacking. Now this is only happen. Na? It means if you will take this part, you will say CS3 Mg X will be the Grignard reagent. Then remaining will be this left, this double bond O, this. Or someone will say, sir, I will take this as a part. What you will say? CS3 MgX. Again, this left. Ringa, chinga, pinga, double bond O. Someone will say, no, sir, I will take this as a Grignard reagent. So what is left? This left, double bond O. Over here, ET, 2 carbon, na? Means this 1 and 2 carbon. ET, MgX is there. So it depends. Now over here, sir. So over here, 3 possibility, 2 possibility is same, 1 possibility is this. Means if Grignard reagent is given, then you will remove that part, remaining all you will write. Suppose I will write one more example. Ringa, chinga, pinga, hinga, bhatinga, chartinga, martinga, over here OH. And I am saying, tell me RMGX. Suppose I will say, कि over here something is coming from A and RMGX. What is R, what is A? So see, understood. OH is here, leave this part. One side this total. So your possibility, you will take this as R. So CS3 MgX. Remaining will be over here double bond O, this side aldehyde, this side as it is. Someone will say, no sir, I will take this side R. So what you will write? This total, this, over here MgX, and this side will be aldehyde, this double bond OH. So like that you can solve the question, and I hope you understood what I am trying to say. Everyone, see it once. If any doubt, 9267937718 with questions also I will dictate. Means this is all about the preparation of alcohol from Grignard reagent. Sometimes they will ask directly, sometimes they will ask indirectly. So we have completed all the preparation of alcohol. Preparation of alcohol done. Now next lecture I will start chemical properties of alcohol. After that ether, after that phenol, and then I will try to complete this chapter. Bye. Have a nice day. Enjoy. Take care. Stay home. Stay safe. Hello students. Very good evening, good afternoon, good morning, whenever you are watching this lecture. So in the last 2 lecture I have completed the method of preparation of alcohol totally. Now we are going to see chemical properties of alcohol. After that ether, after that phenol. Now chemical properties of alcohol. First chemical properties is acidic nature of alcohol. Acidic nature of alcohol. Now before knowing acidic nature, you know that na, कि if Ka value increases, acidic strength increases and pKa value decreases. Means we can say कि if more is the pKa value, less is the acidic strength. Any problem? No sir. And you have studied already these things, and you already know if you are coming over here for organic chemistry. Now after dictating this, we are going to see the chemical properties, acidic nature of alcohol. In that I will take some reaction to dictate you. Now suppose I have taken over here alcohol, ROH. Now I am saying कि does this alcohol, when it will react with sodium hydride NaH, or it will react with NaNH2, or it will react with simple sodium, or it will react with aluminum, or it will react with NaHCO3, or it will react with NaOH. I am saying some pK value you have to know. Their pKa value is 16 to 18. pKa value for alcohol, simple alkyl alcohol, is 16 to 18. And rule is that na, कि we have to go from a strong acid to weak acid. We have to go from a strong acid to weak acid. First it will react with NaOH, it will become RONA minus plus hydrogen gas. Yes, it is a strong it is a strong acid, it is weak acid. Reaction will happen. Over here again RONA minus plus NH3 will go outside. Over here RONA minus plus and half mole of H2 because no hydrogen is there. Over here what happened? RO In place of Na, aluminum is there, but aluminum has 3 valency. So whole thrice 3 plus what you will get? Half mole H2. But when you will react with NaHCO3, what will happen? It will form RONA and outside coming H2CO3, and carbonic acid is more acidic than alcohol. So this reaction will not happen. It means over here no reaction. Rule. Strong acid converted to weak acid. Over here weak acid converting to strong acid. So it will not possible. Over here RONA plus OH and H, H2O, and their pK value is 15.7 approximately. It is also converting, pK value is less, more acidic. Over here 16, less acidic, 15.7, more acidic. It means it is converted into weak acid to strong. This reaction is also not possible, means no reaction. Sir, so every pK value we have to know little bit. Water pK value, alcohol pK value, then I will dictate phenol pK value, something you have to know, not all. Remaining you know that over here carbonic acid is a strong acid. So over here no reaction with this, no reaction with this. Remaining reaction will happen, and rule is that strong acid converted to weak. But in these two cases, weak acid, alcohol converted to carbonic acid, and water is more acidic than normal alcohol. Understood? The first chemical property is done. Second chemical properties, I will not dictate you, but I am writing the heading that I have already dictated in haloalkanes, haloarenes. Same thing, why I will dictate you 4 to 5 times. So over here, reaction of alcohol with either SOCl2 or red phosphorus in presence of X2, that is also written as PX3, or NABR in presence of H2SO4, or PX5, or SOCl2, or SOCl2 plus pyridine. You have seen all this reaction over there. In this reaction what happened? You are taking ROH reacting with SOCl2, reacting with SOCl2 and pyridine, reacting with PX5, reacting with PX3, reacting with red phosphorus X2, reacting with HX, or will give RX. X. Over here Cl is there, so Cl. Over here Cl is there, so Cl. RX. This I will not do detailing. Only one thing you already know, कि whenever we have 3 degree alcohol, it will react with HCl in presence of ZnCl2, and this reagent is Lucas reagent, and Lucas reagent 3 degree alcohol will give immediate turbidity. 2 degree alcohol with Lucas reagent 2 to 5 minutes, and 1 degree alcohol with Lucas reagent, no turbidity. And this detailing you have to see, or at room temperature, this detailing you have to see, you can see on haloalkanes and haloarenes. You already know about this, I have dictated, so why I will dictate this again. Understood? Now third chemical properties is esterification. Very important, very important. Esterification reaction means chemical properties. First we have seen acidic nature, strong acid converted to weak acid. If converted to weak to strong, that reaction will not happen. Second one you have already studied in haloalkanes, haloarenes. Third one, esterification reaction. The name of the reaction is esterification, means what is formed? There is a ester formation. What is the formation? There is a formation of ester. Ester is a sweet smelling substance. Ester is a sweet smelling substance that is used for flavoring agent in sweets, or it is used for perfume, like that, etc. So this is ester. Now we are going to see how we will prepare ester. So what we have to take? We have to take acid, C double bond OH in presence of R-OH, and in acidic medium H+. What will happen? Ki sir, this will give OH and this will give H. Sir, this is to alcohol, this is acid. Acid is giving H plus, alcohol is giving OH. You are saying opposite, yes. So this reaction is very important. Suppose they will give, this is 18 hydrogen isotopes of hydrogen, 18 atomic mass. This is 16 atomic mass. They will form ester, R, C double bond O, R dash. Asking, tell me about this oxygen, 16 or 18. So what you will say? This oxygen is 16 coming from alcohol. This part you have to take care. Mechanism I will dictate, don't worry. But from there, this oxygen is coming from alcohol. This oxygen is from alcohol. It means first time acid will give OH and alcohol will give H. Either acid has a property of giving H plus but giving OH, and alcohol will give H. In presence of acidic medium, ester formation will be there. There is a formation of ester. Why this? Cola very, cola very, cola very D. So understood the mechanism. What is the mechanism behind it? So that acid is started giving alcohol. So we have acid is started giving OH. We have R C double bond OH. We have taken this reaction in H plus acidic medium. H plus searching for lone pair. This lone pair also. This oxygen has lone pair also. But this lone pair is localized. Localized. Those who not take part in the resonance. But this lone pair is delocalized. Why delocalized? Delocalized. Why, sir? Because lone pair sigma pi resonance doing. So this H plus is not attacking on localized. It will attack on delocalized. It will attack on localized. What you will get? R C double bond O H over here OH. Now oxygen is getting one extra bond, so it will get plus charge. Once it will get plus charge, after that what happen? Alcohol will come. Over there I have taken H plus. First H plus is attacking. Alcohol will come, ROH. Once the alcohol will come, we know that alcohol has also a lone pair. This over here you will get electronegativity. This lone, I have told you now, whenever no lone nucleophile is there, nucleophile first try to do acid base reaction. If acid base reaction is not there, then pi bond reaction. If pi bond is not there, then sigma bond reaction. So over here lone pair will see pi bond, because acid base not possible. It will come here. This oxygen will break like this. What you will get? R O single bond. Over here OH. Over here OH, oxygen is also very happy. Their plus will go. Over here OH and R. After that, what happen? This oxygen will get H plus. What it will get? H plus. So this will take the hydrogen. Now H plus is coming as a catalyst, going over here as a catalyst. What you will get? RC. Over here OH. Over here OH, and over here OR. This OR is left. H is going outside. So H plus came, H plus gone. Catalyst does not take part in the resonance, does not take part in the reaction. It is only coming to increase the rate of reaction. H plus came, H plus gone. Now from here H and OH2 will go, H2O will go. This negative will return back. What you will get? The product R C double bond O. Over here OR, and this is the formation of ester. This is the original mechanism. 90% teacher coming and saying this will go here, water will go. No, this is not happen, because this is localized. I'm not talking about other teachers. Suppose anyone will say, you will say no sir, it is not happening. This is the mechanism. Because of this mechanism, the OH is going from where? The OH is going from carboxylic acid, and H is going from, see, going na from carboxylic acid. This OH, this is to alcohol oxygen na, it is to as it is na. This is to alcohol oxygen na, it is as it is na. So alcohol is not giving, carboxylic acid is giving OH, alcohol is only giving H. Understood the mechanism? This is esterification. Sometime esterification reaction will follow some other thing also. Suppose you have taken, in place of alcohol acid, you have taken acyl chloride, means acid chloride in presence of alcohol, and you will have to use little bit base in this part, that is pyridine. It will also give RC double bond O, OR dash as alcohol, and this time HCl will go outside. Or you can do this esterification reaction with acid anhydride. It will react with alcohol in presence of H plus. What happen? This will break from here. OH will attack over here, and you will get RC double bond O, OR dash plus. Outside what it is coming? RC double bond O, OH. तो carboxylic acid is coming outside, remaining you will get over here ester. So ester can be formed by acyl chloride also, and ester can be formed by acidic anhydride also, and carboxylic acid to already there in this, understood the esterification reaction. Everyone, any confusion? No sir, we understood it. Tell me the different part. Under confusion, then you will say it. And see, I am not removing this PDF. First lecture, second lecture, everything is there in this PDF, because after completing part by part, I will make one compilation. I will combine all the lecture and make one short. Then you will see one short that will be more benefited for you. Understood? So part by part also you will see. Then one short also you will see. Sir, esterification we have understood. Now, on the basis of esterification, I have taken one example over here. Suppose benzene ring OH is there, and over here COOH is there. Their name is salicylic acid. What is the name? Salicylic acid. And how we will prepare salicylic acid? By using Kolbe reaction. But I will tell you later. Don't worry about it. What is salicylic acid? Everything I will tell you. Kolbe and Reimer-Timer, salicylaldehyde and salicylic acid. But over here we are studying something different. So see over here what is going to be happen and what I am trying to dictate. Over here, suppose I will take first reagent as CS3COOH in presence of H plus and heat. Second reagent I have taken CS3COCl in presence of pyridine. Third reagent I have taken, suppose CH3CO whole twice O in presence of heat. And fourth reagent I have taken alcohol in presence of heat. See, this is acid. So acid to not react with acid, it will react with base. So reaction will happen here. It is also acid. The reaction will happen with this. It is also acid. The reaction will happen acid anhydride na, but this is base. The reaction will happen over here with acid. Means with whenever this 3 is there, what you will get? You will get this. Benzene ring COOH will not touched. Over here OH will go, and remaining part C double bond O CS3 will come. Every part. Over here what happened? CH3 C double bond O OH will be there. OH will go, and this will do esterification. Over here CH3 C double bond O Cl is there. Cl will go, it will do esterification. Over here CH3 C double bond O C double bond O CH3, this will go, this will do esterification with alcohol. But this is already alcohol, so it will do esterification with acid. So OH will be not touched. Alcohol not react, so it will get what? C double bond O. Understanding what I am trying to say or confusion? No sir. OR. Alcohol will give OR. H will go outside from here and it will attach over here. You will get this. And you know that already the name of this compound is aspirin. What is the name? Not dispirine. The name is aspirin. So it means this compound is not aspirin. This compound is aspirin. Understood why I have done it? Because acid will not react with acid. It will react with alcohol. Esterification we have to do, na? So it will react with alcohol. Someone will say, sir, in this reaction, can we do esterification intramolecular? Haan sir, you can do esterification intramolecular. Over here H, over here OH, over here H, over here OH will go outside, and it will do intramolecular esterification also. O C double bond O. This is attached with this, means something like this. Over here something like this. O is there, over here C is there, over here double bond O is there. This is also coming ester, C double bond O, CR. Understood na? So like that, either it will do intra, or if I have to do inter, then acid will react with alcohol and alcohol will react with acid. Like that things will come. So over here one product you have gone, this product I am drawing again and writing all the things about that. That product you have got something like this. O C double bond O CS3 and COOH. Their name is aspirin. What is the name? First part aspirin. Second part, it is also known as acetyl salicylic acid. Acetyl salicylic acid. Third part, it is also known as ethanoyl oxybenzoic acid. All are the names only. I am dictating because JEE it is there, and it is also known as analgesic. It is used in analgesic. So these are all the names of this compound. Aspirin is used for analgesic. Analgesic. So this is all about esterification. Again, I am saying any confusion, any problem, 9267937718, and I am giving this number because if those who will already studying with me, they might know my number, but some new will come, and if they will not understood anything, they will try to see it and try to understood it. Understood? Now next part of the topic, that is called sorry, dehydration of alcohol. And whenever you are going to the doctor and they are saying you are suffering from dehydration, dehydration means what? Removal of water. Removal of water. Your water is getting lack of, your body is getting lack of water. That is known as dehydration. So from alcohol we will remove water, and that process is known as dehydration of alcohol. In dehydration of alcohol, what you are using? Ringa chinga. This also I have dictated in haloalkanes and haloarenes, as well as hydrocarbon, not haloalkanes, haloarenes. Hydrocarbon, you are taking H2SO4 and little bit heat. OH will go from here, it will get positive. Positive will do rearrangement. After rearrangement, positive will come here. This will become beta, this will become beta, this will become beta. Two product you will get one double bond here. Another product you will get one double bond here. It is known as major product. And we know that over here, first important point कि there is a carbocation formation. If carbocation formation is there, then it will do rearrangement. If rearrangement is there, then it will have even mechanism, and answer will be a stable alkene, and a stable alkene is known as set-Giff product, or it is also called Z-Giff product. Z-Giff product. set-Giff and Z-Giff is the name of the scientist. So like that, I have already dictated in hydrocarbon. So I am saying na, before coming over here, hydrocarbon, electrophilic aromatic substitution, haloalkanes, haloarenes, and Grignard reagent, everything you will see, then only you are able to understood. Organic chemistry, I will not give hope I will make you superstar by seeing only alcohol, phenol, ether. Not possible. Understood? So I hope dehydration of alcohol you understood. The next part of the chemical properties is oxidation of alcohol. Oxidation of alcohol, and then alcohol total done. After that we will start ether and then phenol. Chapter done. We are going to see oxidation of alcohol. Oxidation means addition of oxygen. Now over here, suppose I will give RCH2OH. This is 1 degree alcohol. This is 1 degree alcohol. What you have to do na? You have to see ki how many hydrogen is present in the carbon that is directly attached with alcohol group. 2 hydrogen. So 2 OH will attach. One more OH is already there. Means. First what happened? 1 OH will attach. Attaching? Okay sir, attached. Now what happened? This H and this H2O will go outside. Oxygen has negative, it will become aldehyde. R C double bond O H. Now in this carbon, again understood, the carbon that is directly connected with OH, with that carbon how many hydrogen is there? That much OH you have to attach, in which 1 OH is already there. So again 1 hydrogen is there. What it will become? C double bond O OH. Understood? Everyone. Means if I will do directly, what I will say? R, carbon has 2 hydrogen, OH, and 1 OH is present. 2 OH will combine together and remove H2O from here. This negative will go here and you will get this product. Understood the point? Second, suppose you will take CH3OH. How many hydrogen is there, sir? 3 hydrogen. So C, 1 OH, 2 OH, 3 OH, and 1 OH is already present. After that, what you have to do? 1 H, 1 OH will go outside. What it will become? C double bond O, because this minus will go inside. OH and OH. Now I have told you in hydrocarbon कि whenever again 2 OH is left after C double bond O, 1 OH is left after C double bond O, no problem. If 2 OH is left after C double bond O, then you have to over here C, not double bond O. 2 OH, then H2O will get. If C double bond O is there, after that 2 OH is there, it will convert it into carbon dioxide. How, sir? I didn't understood it. Tell me. See, again, what is the rule? Sorry. What is the rule over here? Rule is that, suppose, understood the point. Suppose, again what happened? 2 OH, first water will go, again water will go from here. After going water, H2O, what happened? This oxygen will return back. What you will get? C double bond O, double bond O. And this C double bond O is what? Carbon dioxide only. Understood? So how many H is there directly attached with OH? That will convert into OH and remove water as much as possible. Over here, third example. Suppose I have taken RCHOHR. This is 2 degree alcohol. Now, how many hydrogen is attached with the carbon that is directly attached with this? Sir, 2 hydrogen. CRR, 1 OH already present, and this hydrogen converted into OH whenever you are doing oxidation. 1 H, 1 OH will go outside. What you will get? R, C double bond O, R. Water is going outside. Understood the logic? Suppose I have taken fourth example. R, C double bond O, R, OH, R and R. And then you will do oxidation. This is 3 degree alcohol. What you will say? How many hydrogen is attached with this carbon? Sir, no hydrogen. It means no oxidation. It means how many hydrogen is attached? That hydrogen is converted into OH. If 1 hydrogen, OH, C double bond O will come. 2 hydrogen, 3 OH will come. H2O will go, C double bond OH will come, like that. And if more than that, means understood the logic. 2 hydrogen, 2 OH. 1 OH will go outside as a water and remaining will be carboxylic acid. Over here, 3 hydrogen, 3 OH. 1 water from here, 1 water from here. And it will become carbon dioxide. I will not give disturbance. Over here, 1 hydrogen, OH, water will go, ketone. No hydrogen, nothing is there. I hope you understood it, what I have done it over here. Not understood, see this part once again. Don't get confused. Now, sir, you have written ki H will converted the H that is directly attached with alcohol group carbon, that will convert it into OH. But what is the reagent we will use? You have not said that. So reagent are lots of reagent that you have to learn it. First reagent KMNO4 and heat. Second reagent K2Cr2O7 and heat. Potassium permanganate, potassium dichromate. Third reagent CrO3 in presence of H2SO4. CrO3 in presence of H2SO4. Fourth reagent PCC, pyridinium chlorochromate. Fifth reagent is PDC, pyridinium dichlorochromate. Sixth reagent is Collins reagent. Seventh reagent is X2 in presence of NaOH. Eighth reagent is N-bromosuccinamide. Ninth reagent is copper at 300 degrees Celsius and heat. These are the reagent. In this reagent, these first three reagent are strong oxidizing agent. So in this part, if you are getting first three are strong oxidizing agent. In this part, if you have 1 degree alcohol, 2 degree alcohol, 3 degree alcohol or CH3OH. 1 degree alcohol converted to carboxylic acid. CH3OH, except CH3OH, it is also 1 degree alcohol. It will convert it to carbon dioxide. 2 degree alcohol is converted to aldehyde. It will convert it to, one second, I have written something. No, correct. Over here, 1 degree alcohol, carboxylic acid. CH3OH, carbon dioxide. 2 degree alcohol converted into ketone. And 3 degree alcohol, no reaction. Because 3 degree alcohol does not have any hydrogen that is directly connected with the carbon that is connected with OH. Understood? Yani 1 degree alcohol, carboxylic acid. 2 degree alcohol, ketone, 3 degree no reaction, and CH3OH carbon dioxide. In with these three, remaining from 4 to 8, it is known as mild oxidizing agent. It is known as mild oxidizing agent. In this case, 1 degree alcohol, CH3OH, 2 degree alcohol, and 3 degree alcohol. 1 degree alcohol converted into aldehyde, not carboxylic acid. CH3OH converted into formaldehyde, not carboxylic acid. 2 degree alcohol converted into ketone, and 3 degree alcohol no reaction again. So 1 degree alcohol, aldehyde, CH3OH, formaldehyde, that you have to take care. This reagent, oxidation does not mean every time this will happen. This to I have dictated what do you mean by oxidation, but according to reagent the things will happen. Understood? And a special reagent we have, very very important, and again this is my one of the favorite question. It may be the question will come from this part. So what I will say, in this part what happen, everything will be as it is, like 1 degree OH converted into aldehyde without any doubt, CH3OH converted into formaldehyde without any doubt, like 4 to 8. 2 degree alcohol converted into ketone without any doubt. But 3 degree alcohol up to now doing no reaction, it will converted the 3 degree alcohol into alkene. This is the best part. Means suppose ringa, chinga, pinga, OH is there, 3 degree alcohol, in presence of copper, it will converted into alkene. This is the best part of this last reagent. So how many star you can put? You will put over here for the 9th reagent. So this you have to know as it is what I have written regarding oxidation of alcohol. This though I have dictated how the oxidation will happen, but according to reagent the things will happen. Suppose I will take some example to make you understood. Suppose first example I have taken ringa, chinga, pinga, hinga, linga. Over here I have taken OH. Over here ringa, chinga, OH. Over here CHO suppose I have taken. Now I am taking the reagent from 1 to 3. 1 to 3, 1, 2 and 3. 1, 2 and 3, first, second, third I have taken. So 1, 2, 3 what will happen? 2 degree alcohol converted into ketone. This is 2 degree alcohol. Na? The 2 degree alcohol converted into ketone. This is 1 degree alcohol. So it is converted into carboxylic acid. This is aldehyde. Aldehyde will also converted into carboxylic acid because already aldehyde will come. Aldehyde is coming from 1 degree alcohol. So aldehyde will also convert into carboxylic acid. If 4 to 9 you will take, what will happen? 2 degree alcohol converted into ketone. Over here aldehyde no touching. Over here this will convert into alcohol because 1 degree also converted into aldehyde, not alcohol. Alcohol is already there. 1 degree also converted into aldehyde, not carboxylic acid. Not carboxylic acid. Understood the point? Suppose I have taken second example ringa, chinga, pinga. Over here OH and copper and heat you have taken. So you will say 3 degree alcohol, sir, 3 degree. So it will convert it into most stable alkene. Understood everyone what I am trying to say or not understood? Everyone. Sometime they will say ki sir in place of PCC they will draw the structure. So you have to check the structure will be given something like this. Nitrogen, pyridinium, then chloro, then chromate, CrO3. PDC reagent will be pyridinium, N is there. Then after that Cr2O7, dichromate, pyridinium dichromate. It is chlorochromate, it is dichromate. Acha, sometime Collins reagent will be 2 mole of pyridinium and CrO3. This reagent name is Jones reagent. This reagent name is Jones reagent. Sometime they will draw the structure of this. So don't get confused. Sir, what you have written, we didn't understood it. Okay? Understood what I am trying to say? Everyone. So sometime they will write directly. Sometime they will write like this. And according to that, you will try to solve this. Any confusion, you can ask me. After that, last special oxidizing agent. A special oxidizing agent, a special oxidizing agent is MnO2. A special oxidizing agent is MnO2. MnO2 oxidizes only allylic and benzylic alcohol. Only allylic and benzylic alcohol means, suppose I have drawn one structure over here like this. Over here double bond. Over here I have put this. Suppose I will put double bond here. Over here I have put OH. This. Over here I will put OH. Over here I will put OH, and I am asking कि I have taken MnO2. What you will say, sir, this alcohol is allylic. This allylic means after double bond there is a carbon, on that carbon OH is there. After double bond there is a carbon there, that is OH is there. This is not allylic, so there is no reaction. This will convert into ketone, ringa chinga double bond. This will also convert into ketone, and they will not touch this alcohol. It means only allylic and benzylic alcohol. Benzylic means, suppose I have given like this. Over here we have CH2OH and I have taken MnO2. So this is benzylic alcohol. It will convert it into aldehyde, not ketone. Suppose I have taken ringa chinga pinga hinga hinga. Over here CH3 and OH. It will convert into MnO2. If you will take, it will convert into ketone, because it is also benzylic alcohol. It is also benzylic alcohol, double bond O. If no hydrogen, double bond O. If any hydrogen, then aldehyde. Understood? So this is all about the oxidation of alcohol, and alcohol totally finished in 3 parts. Understood, everyone? Any confusion regarding anything, you can ask me on my WhatsApp number. Already I have given. Bye. Have a nice day. Enjoy. Take care. Stay home. Stay safe.